Welcome to next video. Today we will see how to write an algorithm to perform insertion and deletion on the queue. So we are going to implement the queue using array. So we have taken one array from index 0 to 5. This is our array for which we have given the name as queue. So we are going to implement the functionality of queue on this array. So first we will take sorry, integer queue. This is my array which is of size 5. So to here, as queue has the FIFO functionality, that is first in first out, so there has to be two ends, one to insert and one to delete. So we need the two pointers, or we need two variables. One is rear and second is front. So one we need rear, which initially is initialized to -1, plus int front equals to -1. So these two pointers, rear and front, are used to perform operations on queue, to keep the track of insertion and deletion on queue. So one thing to always remember is to perform insertion, that means to perform in queue. Whenever we have to perform in queue, we always have to make rear plus plus. That means we have to increment the rear by one index or by one position. Similarly, if we have to perform a deletion or DQ operation, then we have to increment this front. So for NQ, rear plus plus, and for DQ, front plus plus. This is something which you have to remember all the time. So front and rear both are initialized to -1. Now, next, we are going to write a function void NQ, and here we are going to pass an data that we have to insert, suppose x. So this x could be 10, 20, 30, 40, whatever, whichever value that you are going to pass to this function. So this is our NQ function. So this NQ function, we are going to divide into three steps. We are going to categorize into three steps. 1, 2, and 3. We will see these three steps one by one. So the first case is to check whether queue is full or not. If the queue is full, then we won't be able to insert any new element into the queue. So always, whenever we start the queue function, first condition is to check whether queue is full or not. If the queue is not full, then it will go to the next condition. So next condition to check to insert our first element into the queue. If the queue is not full, we will check whether it is a first element or not. If it is not first element, then it will go to its third condition where you'll insert all the rest of elements. We'll understand why we need to categorize this. So first we will suppose we have to insert an elements 10, 20, 30, 40 and 50. So now at the initial stage, my rear equals to -1 and front equals to -1. Correct? So now whenever we have to insert any element into the queue, what we have to perform? We have to perform rear plus plus. Insert, we have to perform rear plus plus. So right now my value of rear is -1. After making it rear plus plus, my rear will point to 0. That is, this is my rear which is pointing to 0. after incrementing rear plus plus. So whenever we are going to insert this first element, so now we are going to insert this 10 element. So this situation will come under my second condition. So I'll write here first statement will be rear plus plus. So we made rear plus plus, rear which was pointing to -1, now it is pointing to 0, and we will save this 10 to 0th location, means where our R is pointing. So the next step will be how we store the element Q. Q is the name of our array. So Q of at which location? At rear location. So Q of rear, rear is our index equal to 10. So 10 will be inserted into rear of Q. So how this will be implemented? So Q of rear equals to 10. Means what is Q of, what is the value of rear? Rear value is 0. So it will be like Q of 0 equals to 10. So we will save Q of 0, 10. What is Q of 0? This Q of 0. So we will save, I'll take another color, and 10. So we have inserted our first element. But this has one more additional step. One more additional step of this front -1. So whenever we are going to insert our first element into the queue, we also have to increment this front pointer, because when we start the deletion, at the time of deletion, the element which is at the 0th location. So at the deletion, we are going to track the deletion by using this front pointer. So whenever we have to perform the deletion, we will be starting from the 0th location. So it is necessary to point this front to the 0th location. So in the when we are going to insert the first element, we will also make front plus plus. So the front which was pointing to -1, now it will also point to 0. Means when we are going to insert the first element, we are making rear plus plus as well as front plus plus. Means these two values, which was initially -1, we are making it at 0 at our first step, at our first insertion. So you should always remember, whenever we are going to perform the first insertion, we have to make this both these two elements point to 0. So next, so we have inserted this 10. Now next is we have to insert this 20. So it will check whether queue is full or not. So currently we have not written anything. So it will check queue is not full right now. Consider it, and it will go to come to the next condition. It will check whether this 20 I'm going to insert is my first element or not. It is not my first element. So it will come to the next condition, that is rest element. So for the rest element, what we have to do? We have to only make rear plus plus. So rear plus plus. So the rear value now which was pointing at 0, now it should point to 1 after making the increment. So rear plus plus, rear value is 0. After increment, my rear will be pointing to -1. Sorry, rear will be pointing to 1, and front will remain at the 0th location only. So after rear plus plus, R is pointing to 1, and next is we have to save this 20 into next location, that is of R. So again I'll write Q of rear equal to 20. So what is, how it will interpret Q of rear equals to 20. What is the rear value? Rear value is right now 1. So Q of 1 equal to 20. So what is, where is Q of 1? This is Q of 1. So I'll insert 20. Okay. Taking one more example. Next. Next is 30. So 30, again it will check first condition. It will fail. Again it will come to the second condition. It will check whether it is first element. No, the first 30 is not going to be my first element. It will come to the third condition. In that, here it will make rear plus plus. What is the value of rear? Currently it is 1. After incrementing, it will point to 2. So currently my rear is pointing to 2. Next step is q of rear equals to 20. So here now here there will be 30. So q of rear equals to 30. So what is the value of rear? That is 2. So I'll write here q of 2 equals to 30. So where is my q of 2? This. So I'll insert 30 here. And if we insert one more element, this r will be shifted to one more location. And again, if I have to insert one more, suppose here we can say, here we will insert 40. If we have to perform one more insert, this q will point to 4. And here I'll insert 50. So now if we have to insert one more element, suppose let's say 60. Now it will come into this condition, whether q is full or not. If the q is full, it will print here q is full, and it will not go into the rest of these two conditions. So this is how we are going to perform insertion into the queue. Here, the important step is to remember these two cases, inserting first element and inserting rest of the elements. While inserting first element, we have to add this additional step front plus plus only at the time of inserting first element to bring this front from -1 pointing to the location of 0. And in the rest of the elements, we'll only increment this rear plus plus and we will not increment this front. So now we will write all these steps into our function q. So the first step is to check whether q is full or not. So how to check whether q is full? By checking this rear value. If rear is pointing to its max size of the queue, that is 4, that means queue is full and we won't be able to insert a new element. So here, first step is to write if statement. If rear is pointing to its max size, that is 4. If this is true, then here I'll write a printf stating queue is full. So if the queue is not full, it will go to its next condition. Now next is to write our condition for this first element. So here I'll write else if. Now how to check whether it is first element or not? So at the time of insertion of this first element, what was the previous stage? That my both front and rear both were pointing to -1. That means if both these two are pointing to -1, that means my queue is empty. And if queue is empty, whatever the element I'm going to insert, that will be my first element. So to check this condition, first element, we will write if front equal to -1 and rear equal to -1. If both these values are pointing to -1, that means queue is empty, and this case will fall into our second case where we have to insert our first element. So if this is true, at that case, in that point, I'll write two conditions. First step is to make rear plus plus. Then we'll write Q of rear equals to what we have to insert. We have to insert here X element. So we will write equals to X, and we'll make front also plus plus. So this will be our is else if condition. Now, after completing this, what is the third? For this rest of element. So this will come under our else condition. If the cube is not full, if the element is also not first, it will directly come to the else part. Here, as it is, same will write the same part that we have written here. That is rear plus plus and q of rear. We have to save this x equals to x. So this is our complete entire NQ function to insert an element into the cube. This is the final algorithm for insertion in cube, and these are the steps that you should remember. And this will be the final step-by-step representation of insertion in cube. We will see the deletion in the next video.